Hi everyone. Today we're going to continue talking about the idea of solving systems with substitution. However, we're going to add another layer to that. Okay? So when solving systems of equations by substitution, and neither one of the equations has a variable isolated, meaning by itself, then solve one of the equations for x or y first. So basically what I'm saying here is that if you don't have y equals something or x equals something, then you first need to figure that out before you can substitute. Okay. So let's try an example so you can see what I'm talking about. It says solve each of the systems of equations. Example 1 reads negative 5x plus y equals negative 2 and negative 3x plus 6y equals negative 12. So the strategy that we're going to use here is to look at each term that has a variable. So I'm looking at negative 5x, I'm looking at positive y, I'm looking at negative 3x, and positive 6y. Out of all of those, I'm going to identify the x or y in either equation that seems to be most by itself already. So if I look at this negative 5x, that means negative 5 multiplied by x, meaning that I still have to divide. Negative 3 multiplied by x, I still have to divide. Positive 6 multiplied by y, I still have to divide. But this right here is just plus 1y. And even if I divide by 1, dividing by 1 keeps everything the same. Okay? So, as a result, what I'm going to choose to do is try and get this y alone. So I'm going to write this out. Negative 5x plus y equals negative 2. And if I'm trying to get this alone, then I want to use inverse operations to get rid of this negative 5x. So how do I do that? I create a zero pair, so I'm going to add 5x and add 5x here. This is like what we did in homework 1. So now this is y equals, these are not like terms, so I just bring down 5x minus 2. At this point, I do have y by itself. So now that I have that, now I can just follow the steps from homework number 4 and substitute this y, this value of y, into a second equation for this y. Okay, so let's go ahead and do that. So I'm going to rewrite negative 3x plus 6, but instead of y, I'm going to write 5x minus 2, and just keep writing equals negative 12. And everything from here on forward is something that we've done before, so I'm going to use the distributive property there. So that's negative 3x plus 30x, I multiplied 6 and 5x, 6 times negative 2 makes negative 12, equals negative 12. I see like terms, so I'm going to go ahead and combine those. That makes 27x minus 12 equals negative 12. I'm going to add 12 here and add 12 here. That makes it 0. This also makes 0. So now I'm just left with 27x is equal to 0. If I was to think logically to myself, 27 times what makes 0? That means that x must be equal to 0. Okay, so now that I know what x is, just like I've done in the past, I'm going to take one of these equations, I'm going to choose this one right here, and I'm going to substitute x, or 0 for the x. So now I'm going to write y equals 5, but instead of x, I'm going to write 0 minus 2. So y is equal to 0 minus 2, meaning y is equal to negative 2. So my final solution here is 0, comma, negative 2. Okay. Again, the main idea here, the main difference between what we're doing today and what we did last time is just at first, we need to figure out which of the variables we want to get alone. So let's look at example 2. I see x minus 10y equals 20 and negative 3x plus 5y equals 15. Again, I want to look at all of my terms with a variable, and I want to identify which one is not being multiplied by anything, which one might be easiest to get by itself, which one might be easiest to isolate. So x only has a 1 in front, negative 10y, that might be a little bit more difficult, plus 5y might be a little bit more difficult, negative 3x might be a little bit more difficult. So what I want to get alone is this 1x. Okay, so even though we're not solving for y, we're still going to use the same strategies. So I'm just going to rewrite this, x minus 10y equals 20. Now if I want to get this x alone, then anything on that side with the x, I want to get rid of. So if I want to get rid of this negative 10y, just make a 0 pair with it, I add 10y, add 10y to the other side. So this becomes 0. So now I'm left with x is equal to, again, these are not like terms. 10y has a y. 20 does not have a y. So it'll be 10y. And this is a positive 20, so I write plus 20. That quickly I was able to get x alone. So now, since the whole method is called substitution, I'm going to take this value and substitute it in for this x right here. Okay, so I'm going to rewrite it, negative 3, but instead of that x, I'm going to write 10y plus 20 plus 5y is equal to 15. So again, all I'm doing is replacing the variable with something that it equals. Negative 3 multiplied by 10y makes negative 30y. Negative 3 multiplied by 20 makes negative 60. This 5y is not in the parentheses, so I just rewrite it, equals 15. So negative 30y minus 60 plus 5y equals 15. I see any like terms I have. I see negative 30y and positive 5y. So I'm going to bring those together. So that's like negative 30 plus 5. Since they're different signs, I'm going to subtract and make that negative 25y. Bring down my negative 60 equals 15. At this point, I'm still trying to get y alone. So I want to get rid of anything else that I can, make a 0 pair. So this makes 0. So now I just bring down my negative 25y, and that's equal to 75. I divide by negative 25 because that's the inverse operation of multiplication. And I'm left with y being equal to negative 3. 75 divided by 25, 3/4. That's a way that I'm thinking about that. Y is equal to negative 3. Now that I know my y value, y is equal to negative 3, then I can take this negative 3 and substitute it in for this y up here. So I'll rewrite x is equal to 10, but instead of y, I'm going to write negative 3 plus 20. 10 multiplied by negative 3, that's negative 30 plus 20, which makes negative 10. So my final solution is negative 10, comma, negative 3. Okay, we're going to move on to the next examples. Pause and try the next couple or the next few steps on your own. Example 3. Example 3 says x plus y equals 3 and 3y plus x equals 5. So this is an interesting situation because if I look at all of the variable terms, actually I could go many different routes this way. This x is really close to being by itself, this y is really close to being by itself, and this x is also really close to being by itself. This is probably the only option that would make things a little bit more difficult. So you could start in a bunch of different ways on this example. I'm going to choose to solve for this x right here. So I'm going to rewrite this equation, x plus y equals 3. I'm trying to get this x alone. So I'm going to put in my 1y just to make sure that I'm clear about that. So anything that's on the side of the x that I can get rid of with a zero pair, I'm going to go ahead and do so. So that would be negative 1y here. This makes 0, so now I have x is equal to negative 1y, and this is positive 3. So I got x to be by itself, so now I can take this value of x right here and substitute it in for the x in the second equation. So I'm going to write 3y plus, but instead of the x, I'm going to write this negative 1y plus 3. And then continue to copy down the rest of it, equals 5. So this means that I have a positive 1 out in front. Positive 1 multiplied by negative 1y is still negative 1y, and positive 1 multiplied by positive 3 is still positive 3. So you can just remove the parentheses. Okay, so now you got 3y, 1 times negative 1y makes negative 1y, 1 times positive 3 makes positive 3, equals 5. I see some like terms, 3y, negative 1y, or 3y minus 1y, and those together make 2y plus 3 equal to 5. I want to get rid of anything that I can make a zero pair with on the side of the variable, so I'm going to get rid of this positive 3. This makes a zero pair, so now I've got 2y is equal to positive 2. I divide by 2, the inverse operation of multiplication, and y is equal to 1. Now that I know what y equals, I can take this value and put it in for this y right here. So I'm going to rewrite x is equal to, so x is equal to negative 1 in parentheses. I'm going to write the value of y that I figured out, which is 1, plus 3. Okay? So x is equal to negative 1 multiplied by 1 is negative 1 plus 3. So x is equal to positive 2. My final answer here is 2, 1. Remember, regardless of what you solve first, you always want to go x first, then y. It's always x, y. Okay, example 4. I see 3x minus 2y equals negative 8, and x minus 7y equals 10. I look at each of these variable terms. I notice that this x might be the easiest one to get by itself because it's only a 1x. I don't have to divide by anything. So I'm going to write this off to the side. X minus 7y equals 10. I'm trying to get the x alone, so that means I need to get rid of this negative 7y. So I make a zero pair, balance out the equation. So now I've got x is equal to positive 7y plus 10. Now that I've got this value of x, I can take it and substitute it in for this value of x in the other equation. I'm going to write 3, just from right here. But instead of the x, I'm going to write parentheses, 7y plus 10. That's coming from right here. Subtract 2y equals negative 8. So I use the distributive property, 3 multiplied by 7y, and then 3 multiplied by 10. So 3 multiplied by 7y is 21y, 3 multiplied by 10 is positive 30. I write down negative 2y and equals negative 8. In this next step, I'm going to see these like terms. I want to combine those. 21y minus 2y. Those together become 19y plus 30 equals negative 8. At this point, I want to get rid of anything that I can make a zero pair with on the side of the y variable. So I subtract 30, subtract 30. So now I'm left with 19y on this side, and negative 8 minus 30, that makes negative 38. Divide by 19, divide by 19, that's y is equal to negative 2. Now that I know my y value, I've got part of my solution, figured out my y. Now I need to figure out my x value. So I'm going to take this and substitute it in up here. So that means x is equal to 7, but instead of y, I'm going to write parentheses negative 2 plus 10. So that's x is equal to negative 14 plus 10. That means x is equal to negative 4. So my solution is negative 4 comma negative 2. Okay, again, this would be a good time to pause. Try example 5 and 6 on your own. I am going to try and do those quickly and talk along with it. Example 5 says 5x minus 4y equals negative 3 and 3x plus y equals 5. Immediately I see that this y seems to be easiest to solve for because there's nothing multiplying it. So I'm going to rewrite it, create a zero pair because I'm solving for y, subtract 3x, subtract 3x, so that's y is equal to negative 3x plus 5. I can now take this y value and substitute it in for this y value right here. So I'm going to rewrite this equation, substituting in the y value. So instead of y, I'm going to write parentheses negative 3x plus 5 equals negative 3. So that's 5x. Then here I distribute this negative 4 to the negative 3x and negative 4 to the positive 5. So that's positive 12x and negative 20 is equal to negative 3. 5x and 12x, that makes 17x minus 20 equals negative 3. Add 20 to both sides to create a zero pair. So that means 17x is equal to 17. Divide by 17. X is equal to 1. Now that I know that x is equal to 1, I can take this value and substitute it in up here. So y is equal to negative 3 parentheses 1, or multiplied by 1 plus 5. So y is equal to negative 3 plus 5. So y is equal to positive 2, meaning that my final solution is 1 comma 2. Okay, example 6, this is another situation where I could try and get either of the equations to have x or y by itself. X plus 6y equals 20, I notice this x is almost by itself, and x plus 3y equals 14, I notice this x is almost by itself. Either way, we'll end up with the same thing. I'm just going to choose the top one. So x plus 6y equals 20. I'm going to solve for x, meaning that I get rid of the 6y. That makes a zero pair, so x is equal to negative 6y plus 20. I've got this value. I'm going to substitute it in for this value of x down here. So I'm going to rewrite it. It'll be negative 6y plus 20 plus 3y equals 14. Since there's just a 1 in front, I can just get rid of these parentheses because it's not a negative 1, so everything will stay the same. I can just take them out of parentheses. I found my like terms, that's negative 6y and positive 3y. Together those make negative 3y. Bring down my plus 20, or my positive 20, equals 14. I'm going to subtract 20 and subtract 20 here. That makes a zero pair, so now I've got negative 3y is equal to negative 6. I divide by negative 3, the inverse operation of multiplication, so y is equal to positive 2. Negative 6 divided by negative 3 makes positive 2. Now that I know what this y value is, I'm going to take this and substitute it up here. I'm going to rewrite x is equal to negative 6, but instead of y, I'm going to write positive 2 plus 20. So that's x is equal to negative 12 plus 20, meaning that x is equal to positive 8. So that's 8, 2 as my final solution. That's a video for today. If you have any questions, please ask me. Please come into office hours. Thank you very much.